Morning everyone, how are you? Thanks very much for coming this morning to using BIM to control energy in the built environment. I realise it's an early morning start for some people and you have a lot to be up to, so it's appreciated that you're here. It was called a breakfast briefing, but I didn't actually think there would be breakfast. I thought that was just a trick to get you here, so I was relieved when I seen that buffet over there. My name is Eamon Shields from SEAI, and I've recently joined SEAI. I spent 20 years in the private commercial sector as a building services engineer. I joined SEAI about 3 or 4 months ago, and I've joined the business section, and I'm involved in commercial retrofit. I've used BIM in my previous role, obviously, but I think in terms of SEAI, there's huge changes happening in SEAI at the minute. And I think with the task that we all have, and not just SEAI, the task that we all have ahead of us, it's important to us that we use every single possible tool and every single society out there to achieve what we need to achieve. And BIM is just an example of that. Other elements are smart buildings, all the other types of technologies that are out there, building optimization. But I think we've seen from the target that we have ahead of us that it's important that everybody does their part, but it's important that we engage with everybody that's trying to do their part and help promote what they're doing in that regard. And this is just an example of that. So I'm just going to give you a quick rundown of everyone here today. So we've got Michael Curran. He's the chairman of CIBSE Ireland. Michael is the head of Building Services, Energy and Utilities in Nui Galway. He's a graduate of the University of Liverpool. He worked as building services engineer before taking up his current role as energy performance officer in Nui Galway. Michael led the team to ambitiously exceed government targets in primary energy reduction, also winning the SEAI Energy Team of the Year 2019. He has represented CIBSE Ireland at numerous SEAI events and worked closely with the U9 group of energy officers across the university sector on developing strategies to achieve targets set out in the Climate Action Plan. Michael is here at the end. Just in case anyone doesn't know, there's probably a little clicker here I can use to show people. There he is. That used to be what I looked like before COVID, just in case anyone thinks I'm an imposter. Avril Behan is Project Director of Build Digital Project. Dr. Avril Behan is the Project Director and a $2.5 million project funded by the Department of Public Expenditure and Reform, creating a national centre of excellence of digital construction in Ireland. As part of priority actions of the Construction Sector Group's Innovation and Digital Adoption subgroup. Avril holds a PhD in the application of geomatics to architectural historical studies. Her research interests include all aspects of building information modelling and management, particularly for energy performance and the integration of geomatics technology, applications of analytics and machine learning in construction, collaborative education, and full set of life cycle management. The integration of lean construction with BIM is also an area of special interest. Next up, we have Michael Earley. Michael is the BIM manager with DAA and a member of the digital transformation team responsible for implementation of the BIM strategy and integration of systems to ensure the seamless transfer of information during the life cycle of physical and digital assets. Part of the strategy is to deliver projects in accordance with ISO 19650 standards and to utilize digital tools such as BIM 360, Autodesk, Forge, ESRI GIS, and Maximo to improve the quality of information that is used to design, construct, operate, and maintain assets. As chair of the RAAI BIM committee, Michael is responsible for the development of the RAAI BIM pack and is also a member of the NSAI technical committee, which published the national annex to ISO 19650. Michael is very welcome here today. Maddie. Joe is on the end. Oh, he's in the middle actually. Joe's in the middle. Chief Executive Officer of DCT Group. Joe is a member of the CIF4 Committee, a member of the NSAI Technical Committee on BIM, and a member of CEDA BIM Eastern Region Steering Committee. Industry work aside, he is part-time lecturer as TU Dublin, where he lectures on the CPD, Digital Delivery for Site Teams, and the Construction Site Management course. Having initially trained and worked as an electrician, he attended further qualifications with a BEng Tech and Building Bachelor of Science in Electrical Engineering Services Design, as well as a Master's in Applied Building Information Modelling and Management from TU Dublin, and a Master's in Leadership and Management in UCD. And I can also say that Joe was the one that convinced me that BIM was something to go with his cult-like enthusiasm. I didn't have much choice, so he eventually won me over. And last but not least is Alan Harr, who's kindly stepped in to take the place of Brian McCormick, who was called away at short notice. So Brian's from TU Dublin, and he is the head of School of Surveying and Construction, founder of Construction IT Alliance of Ireland, who is currently involved in the Build Digital project, and he is co-chair of the Digital Procurement Pillar. So at that, I will hand over to Alan and let him take it from there.
Thank you very much. Thank you very much. Delighted to be here this morning. I just want you to take a deep breath for a second and have a look at that figure that's on the screen. This is a phenomenal statistic that 39% of CO2 emitted from buildings is a consequence of our building operations and our construction. This equates to 36.3 billion metric tons emitted into our atmosphere. So we as an industry have a collective responsibility to do something about this. Building operations are responsible for 28% annually, and the balance is responsible for the embodied carbon. The World Economic Forum estimate that by 2060, the footprint of buildings in this world will have doubled, making it even more serious problem. The global footprint will increase, and the World Economic Forum also reckon that less than 3% of that building stock is green and efficient. So what we have to do as an industry is halt this climate change, and the building and construction industry have a responsibility that we need to step up to. So this is what this morning is about. So let's look at this a little bit more detailed. CO2 emissions from buildings, as I said, this year has increased by 10 billion metric tons. Incidentally enough, during COVID-19 and during the predominant global lockdown in many countries, the actual emissions have reduced by 10 billion metric tons. So we can see what we can do when we have a more controlled environment. It's also very interesting to see that globally, and not too far from this country, local authorities are making decisions not to grant permission for planning as a consequence of the potential impact of the building on CO2 emissions. Two examples: the Tulip Tower in London and the new headquarters for Marks and Spencer's in Oxford Street, both halted as a consequence of the impact that they reckon those buildings would have on the environment. 30% of global energy use comes from our buildings, and nearly 55% of global electricity. And these figures, that figure of 39% doesn't include the emissions coming from our power stations globally. And the other startling statistic is that we're not doing enough in decarboning the industry, i.e. storing carbon or extracting carbon from the atmosphere before it damages our ozone layer. And between 2016 and 2019, we only managed to, the annual carbon progress almost half. In other words, we're not doing particularly well. In Ireland, we have 3 plans. We have a housing action plan, we have a national retrofit plan, and we have a climate action plan. But my concern is they're not connected cohesively enough. Direct CO2 emissions need to be halved by 2030. That's what, 8 years away? If we're to get back on track to net zero carbon by 2050. So ladies and gentlemen, this is a serious problem that we need to address. So this morning what we're going to do is we're going to look at the built environment life cycle: plan, design, build, operate. What can we do with each of those stages? So we have our experts this morning. So Michael will be taking us through the plan phase. Joseph will take us through design. Arva will take us through build. And last but not least, Michael will take us through operate. And then we'll kind of reveal to you why we're doing that in that particular sequence. So our first speaker, Michael, you're very welcome. So I'm going to take some notes, because apparently this is recorded and I have to have a quote from each of the speakers. But please be free, once we get through the presentations, to ask questions of the speakers. Thank you.
Okay, good morning everyone. My name is Michael Earley, and as mentioned, I'm with DAA and Dublin Airport, Cork Airport, and recently we've been awarded the contract to look after Jeddah Airport and the Red Sea development. So and we do look after retail facilities around the world as well. So very much what we're doing is we're looking after a lot of built assets, both in terms of buildings and also in terms of infrastructure, such as runways, roads, and so on. So we've a huge responsibility to make sure that we're actually part of the solution to the problem that we all know about. And we're now starting to understand both the complexity and I suppose the enormous challenge we've got with that. So I'm just going to go through initially just some of the sort of things we're starting to look at now. I suppose we have looked at them, but we're basically now getting, I suppose, extremely serious about this. So what we have in the airport is we have a BIM champion, which is myself. We also have a sustainability champion as well. And so we're now starting to do, I suppose, 2 things, big things at the moment. One is trying to take a holistic view of what we're doing. So you have to start off with the holistic, because you can get into a lot of detail trying to solve things in BIM, but if you're not trying to actually solve the right problem, or you're trying to do something or spend a lot of time and effort on something that's getting little gain, it's going to be counterproductive. So basically we've defined a set of sort of KPIs, if you want to call it that, that we need to achieve by 2030, and this is really important. On this slide on the right, I think this is one I find I think very important. The amount of money spent on capital infrastructure, even though that's one of the challenges we have, that's only a small percentage of how much time, money, carbon, effort, everything that goes on after the actual building is handed over. And I suppose if I want one thing to take away from today is that what we're designing and building today, those buildings are going to be with us for much longer than all the buildings are how we have considered building infrastructure at the moment. We're seeing buildings being put up, torn down all the time, new and better buildings, and that's all fine to a degree. But I think what we're building today, we are going to be retrofitting pretty much everything we do. So it's going to be really important that we actually start to have really good records of what we're putting in, because we're going to be taking those buildings apart, refitting them out in much more considered detail than we've been doing up to now. So, okay, so what just on this slide, I think what I want to put across here as well is we have sustainability. That's our number one priority at the moment for all our built infrastructure. There's nothing more important than sustainability. We are considering other things, adaptability of buildings, identity of the buildings, well-being for the participants in the building. That's our staff, people who come to visit the airports and so on. The efficiency of those buildings and the durability of the building is really important. But we need to start to get those things into definable and measurable, and not just definable as in these things are important to us, but get them into a brief from when we're procuring a building so that these things are well described about what exactly we want, and that can filter down to the main contractor, designers, contractors, down to the subcontractors and so on, that we know exactly what we want. And that's where we want to be. We really need to be in a position where we're sure about what we want, because if we're not sure, that's going to reflect on everything else we do after that. Just one of the projects we're doing, the one on you'll see on the top right, you've probably seen it maybe in the media, we put in a planning application to refit out the top 2 floors on the actual Terminal 1 building. It's not just about aesthetics, that's bringing that building from basically an F up to a B, BR rating. So F, that building was, that you would not do it now. And I think that rating system is brilliant because I think we all get that. We know it in our houses. We now know it in our office buildings as well. It's a very general rating, but it really does put a focus, I think, for most people on how good the performance of a building are. There's many other aspects to that, which we're looking at. That's going to be a BREEAM rated building, and we're reusing the building that's there. And I suppose it could be easy. There are people who would say, knock down that building, it's starting to look ugly. But the amount of embodied carbon in that building, and if you had to knock that down and do something else, would be significant. So how are we achieving all this? What we've done is in the last sort of 3 years, or shortly after, prior to me starting in DA, this system was set up. These are our project stages. They're very similar to the RIBA stages. So what those stages mean is these are things we do at particular stages, and we don't let a project go to the next stage unless all the checks and balances from the previous stage are identified. So what we have done now is we've actually set out sort of standard process, and I've got a BIM sort of one for this, and now there's also sustainability one for this. So at the very beginning, it's all about assessment of need, and that's really the important part. We need to do a proper assessment. This is the real holistic sort of part of the actual exercise. That could be, do we need to knock down this building? Who's going to use this building? How often is it going to be used? Do we need to heat all the areas? We get into all those sort of things when we're at the early stage of the building. And we have to get all that done before we get into the detailed design. And that's, if we don't get that right, the detailed design is going to be, will be struggling all the way. So that's just, actually on the right there, it's just a section through, a 3D section through the actual, that terminal building. So we're starting to really look at the actual, we did a whole assessment of the structure of the building. We started to look at the actual, when we put on the facade, how we optimize every aspect of that facade. So north, south, east, west, that's all modeled. We can do the energy assessments on that. And what we're doing, I'll show you a slide in a couple of minutes, we're doing an energy assessment on all the, starting to commence an energy assessment on all the buildings in the campus. So this is our pyramid system. As you can see, sustainability is one of the, well, this is the one for sustainability, but I would say if we're to look at everything we're doing at the moment, sustainability is top of the list. So how do we implement all that? So we have policy at the top. The policy would be, like I showed you in the slide earlier, that's to reduce our carbon footprint by a certain amount, reduce the amount of energy we're using, use less water and so on. Strategy then gets into a bit more detail on that and establishes the guiding principles. The management systems then, that's basically how do we know if we establish a policy and we have a strategy for that, how do we know we're getting that? And that's going to be really important, because I think we have to get away from the kind of the greenwashing. We have to be actually we have to know that what we're doing, we think we're doing, is actually happening, is that meeting targets. And we're now establishing a whole basis of reporting for that. So we're now, let's say one of the examples is we're doing an IES model for a building. We want to get that as accurately reflecting what we have as existing before we do another thing on that building. And then we want to know then, is the intervention starting to actually make a difference on that building? And if it is, then it doesn't match the reality. So that's going to be really important for us. So verification and monitoring are going to be extremely important. And then we've a whole set of sustainability guidelines as well to assist with that. Okay, so what we're doing, this is just one of our strategies. What we're doing is we're building what's called minimum sustainability requirements. So these are things that we say, look, for all our buildings, we have minimum requirements. We have requirements for new buildings, requirements for existing buildings, requirements for existing infrastructure, and requirements for new infrastructure. They vary slightly because it's much more difficult to make an existing building bring it up to the same standards, because you don't have control over absolutely everything. But you do get enormous benefit if you reuse that building. So what we're doing then is we have a progress update, and we need to know then basically for every project what we're trying to achieve. Does that transfer into this project? How are we doing on it? If anything starts to slip, we need to know. So that's going to be a really important monitoring tool for us. Okay. So what do we do in terms of BIM? I know I've talked a lot about probably the more holistic side of things. That's the T2 terminal building. You probably recognize it. What you're seeing there basically is the structural model of the building overlaid with all the rooms. We've modeled all the rooms in that building. What we get from that is we know that's the correct orientation for the building. We know every room is there in its own place. And we're now starting to look at that overall building. We're running this through software that'll do an analysis on the building and look at each room, what temperature it should be, what zone is it in, what is it being serviced by, really getting down to the detail on this. And what we're doing, we actually, as a first task here, we have to make a virtual model match the actual, what we perceive to be the way things are working at the moment. And once we get that model properly, then we can start to assess then the actual, any intervention we do. And we need a lot of intervention. So we've got to reduce the actual energy use in that building by 50% in the next 8 years. So that's not just we want to do it. The bills when they come in, and the bills for that, for heating that building are absolutely enormous, and they've doubled in the last less than 2 years. So it's an imperative that we get that done. But just as a summary of what we're doing in terms of BIM tools, we have to model. You can't actually do the analysis without having these models. What we get out of that then is we need to building location correct in the orientation, because that's relative to the sun, wind, everything else. That's really important. We can do shadow analysis on the buildings. We can do thermal modeling, and the two types we're doing is conceptual energy analysis and also detailed energy analysis of the buildings. So conceptual is how much heating will take to heat up that building, or to cool down that building, how much we need to actually protect the outside of the building. We need to understand the building energy consumption then. We do some options on fenestration as well. We look at daylight simulation, so the lighting inside for everyone is good. You can do computational fluid dynamics, and that's much more complex. That's looking at basically how you're getting warm air and cold air around the building. And then there's a sustainable element tracking then as well that we're looking at. And some of these things are very mature, sort of mature, I suppose, and some things we're only starting with. That last one, sustainable element tracking, I'd say that should be today standard practice, and I don't see it happening. So that's something we're starting to look at to see basically how can we identify everything? How can we say that element of the building, like concrete is the best example, which is probably, I think, the fourth most carbon intensive basically material in the world. How do we know how much of that we have in a building? So we need to be able to track those things. Okay, so that's my summary of mine. Thank you very much.
Thank you very much. Just a couple of quotes there from Michael, just to remind you the importance of BIM. We cannot do the sustainability analysis without BIM. And of course, Michael has a grandiose title of BIM champion. So BIM is actually very, very important. A number of important quote from Michael is that sustainability is their #1 priority. More people think like that, we'll get this thing fixed. So our next speaker, Joe Maddie. Joe is, as I say, founding managing director of Digital Construction Technology, is a global digital construction consultancy. He's a BIM champion, another BIM champion. He's also a member of CIF's Mechanical and Electrical Contractors Association. So Joe's going to talk us through the embedded energy, which relates to the design phase of a construction project. Joe, over to you.
Okay, so another BIM champion, as you said. That's it. But so I suppose just to reflect at the start of what we do, we primarily work within the virtual design and construction side of things when we deal with buildings. And I suppose DCT, we work on all sides. So we would work with the main contractor, we would work with the client, we also work with subcontractors. And I suppose at this time, what we're seeing is a lot of the projects that we work on, we're focusing now at this time on, prefabrication. We're looking at modular. How can we build it quicker? How can we build it faster? But if I'm being honest, nobody's looking at how we can reuse and reassemble or unassemble a building at any stage. So what we're going to talk about here is the embedded or the embodied carbon, and look at, that is what, looking at the full life cycle of the building from the start to the end. And at the moment, we currently look at that in terms of when we need to build an asset information model. So usually when we start a project, we would look and say, okay, what do we need at the end in terms of maintaining the building? What information do we need in terms of the full life cycle? But again, what we don't do is we don't look at this. We don't look at how we're going to build the building, how we're going to put the building together, how we're going to take it back apart. And really all we'd have to do in sequence would be, if we have a construction sequence, we just need to do it in reverse, really. So it is a hot topic, and we are looking at it at the moment. And if we take the standards that's being created by the European Commission, there's a number of guidance documents on how to utilise and how to work within the circular economy. And Al pointed out, I had on my statistics 35% of all the greenhouse gas. But also, it's noted within the documents that when a building is demolished, 95% of the building loses its value. And we were looking at this recently for a research project, and it's funny because nobody looks at the value of reusing the building. And in these documents, it shows that there's a lot of value by reusing the elements within the building. But to do that, we have to put it together, we have to monitor, and we also have to track in such a way that we can take it back apart. And these documents highlight that. And again, it's all about sustainability and ensuring that we are trying to, again, reduce our carbon footprint. So as I mentioned, we work within the 3D, within the virtual environment. And if we take, for instance, the 3D model, and we've worked on all types of projects. We're working with Michael at the moment on the hand baggage upgrade in the airport. But we have a 3D model, and if we add some more information to that, we can do the construction sequence. So if we see here, we have 4D and 5D and 6D. So we can do the construction sequence. So if you've seen the different construction simulations, we can do that because we're adding time. So time to an element, and then we build the building. We can also add more information, and then we can add cost. So then we can get the cost of the element. We can also add additional parameters. We can add the carbon of an element. And then we can also add additional information for the operation and look at how that will be affected over time. But there's absolutely nothing stopping us to look, and if we add another level into that, into reuse. And working within the circular economy, it can definitely be done. And it is being done at the moment, and I'm going to give some sample projects. And I suppose to support and enable this at an ISO level, there is a standard for this. It's 20887, so there is an ISO standard for working within the circular economy, and I suppose being enabled to build and disassemble a building. So, we can definitely do this. But to do this, we need to fundamentally change how we design. Also, I worked with Eamon before, And I can 100% guarantee you that when we were designing the building, we really didn't look at when when the building was going to be finished at the end of its life cycle. We're all deal within the construction industry, and it's fundamentally it's not at the center of what we do, and it should be. And it's, as I said, it's a very, very interesting point. But we need to take in other areas. So when we're going to look at that again, designing for disassembly, looking at the material passport. Again, I'm going to speak about that, and then again having that virtual database, which we're already working on. We can do that, but again, it's connecting the virtual model to the physical construction, and that again it can be done. It can definitely be done. So again, the different levels. So when I speak about and we see here the full circle. When we create the building, okay, so we design it, we create it. We need to be in a place, and the guidance documents talks about this, we need to be in a place to monitor the products or the elements. So we can do that in a number of ways. I suppose we can manually do it, so we can go out and visually check. I suppose a visual check will tell us. We can do different types of pressure tests if we're doing concrete tests. We can also do passive tests. So passive tests would be, we can put a sensor on an object and it would give us an indication of the condition of a product. I suppose the easy one would be, a passive would be like a sticker on your, say for instance on your iPhone. So when you go into the shop and say to them, I don't know how it's broke, they'll say, I think it's water damage because the sticker turns red. So again, that would be just a simple indicator that you could put on a product, and that would tell you if it's water damaged. So there's different ways that we can maintain and monitor the products. And I suppose moving on from that then, we can also have sensors. So we could put sensors, and when we think about within the products or within the building elements, and that would be feeding back in real time, back into, again, the virtual model. So this can definitely be done, and it has been tested. So we can constantly monitor the products, because this is going to be a full ecosystem. And when we move from monitoring, we need to also identify. So we're monitoring the products, we know, but when we go out to site, we need to know, okay, we need to identify the products. So one way of doing it would be to embed, what we can see here is embedded RFI into whatever product that we want. And that's not to give all the information about that product, because we'd have to have a way of storing all the data. All we want to do is identify it. So if we say that this door is 1, 2, 3, we just need a way of linking that back to the virtual model, because that's where it holds all the data. So we need to have that connection between the physical and the virtual. And there's a number of ways that we can do this, and here is an example of what type of data we could put with any product. And we do that, and as I mentioned, we do that at the moment. We do that when we create our asset information model. We do create the link between the virtual and the physical. So I suppose when we look at monitoring, we need to monitor, we need to identify, and we definitely need to track. So here's a couple of items that we need to look at and core principles when we look at material passports, because when we track, we need to have a passport, and that's what it recommends within the guidance documents, that we have a material passport, that we can track these materials. And over time, what we will see, previously I spoke about a life cycle engineer, so someone that would deal with the, I suppose, the virtual and the physical management, like a facility manager. But in this, we may or could have a materials manager that would manage the materials throughout the full life cycle of a building. So when a building goes up, you would need to get it certified, as we do. We have all our certs and so on when a building goes up. But also, as if we imagine, if we're taking parts of a building and we're going to reuse it, we need to be able to be in a position to monitor that condition of that product. We also need to be in a position to identify it, but we also need to be in a position to track, trace, and certify, because if we're taking elements out of a building, we're transporting the elements and we're going to reuse the elements, somebody's going to have to certify it. Somebody's going to have to take the liability, on that product. So I think, again, we need to be mindful. So just some examples. This is the circular building in what it was done in the UK. So you can see here the structure. They tried to show the simplicity of how we can build to disassemble, and they used different, I suppose, materials and methodologies to enable this. So it was Arabs on BAM and a couple of other project stakeholders, the Built Environment Trust, created this. And they looked at different ways that they could approach building. So they looked at like leasing the lights instead of purchasing the lights. They also looked at powering this building through a DC power, which was done with a saltwater power supply rather than using materials that couldn't be reused. And again, this was a use case in 2016. So another one that's moved on, again, Arrows was involved in this, in 3XN Architects. Again, they incorporated or worked, again, dealing with the circular economy with Google. So again, they wanted to use different materials that could be reused, that could be repurposed for different uses. Again, you can see the pictures and trying to crack the elements. And here we can see the glazing and trying to feed into the energy use within the building. And the last one here is the 3XN Architects Office. Now, I couldn't find out on this one who was the team that actually built it, but the architects were the leads. It's their office. And what they did was they purchased, it was basically a boathouse in Copenhagen, and that's their head office. But they fundamentally created the building and wanted to showcase, because that's what they do. They would be global experts. They wanted to show how they could put the building together and it could also be taken apart. So when they were upgrading the boathouse, that was key to it. They also created a BIM model, and there was certain things that they wanted. They wanted all the staff to have a full view of the surrounding areas and so on. So again, it can be done. There's a lot more examples of how a building can be created, how it can be constructed to be disassembled. But again, it has to be fundamentally done in such a way that when it goes up, that we're thinking about when it needs to come back down. So just, I suppose, recapping on looking at the circular economy, and when we think about the embodied carbon and how we need to change or fundamentally change our design. As I mentioned from the start, we don't look at this now, and I personally haven't worked on a project that looks at the full reusing and disassemble to reassemble. It's something that really interests, and it came up recently on a project because we were looking at modular, and we were saying once this goes in, because they were basically containers, they're not going to come back out. So it was something that we talked about, we looked at, and at that time it wasn't suitable for what we needed to get the project done, but it's definitely interesting. So I suppose these are the key 15 principles. And I suppose if you look at it from a high level, we need to ensure that we design to disassemble. That's the only way that we can do it, and to bring that carbon. If we want to map the carbon, if we want to reuse products, if we want to reuse elements, we need to do that. Having a material passport, I definitely think we could do that now. I don't think that's a massive thing. We are doing, as I mentioned, we're identifying assets. We're working on Dublin Airport, the hand baggage upgrade, where we're tracking from the physical to from the virtual to the physical, where we have all the data in the model. But then on each piece of maintainable equipment, we have to put a QR code. That's already there. That's just a link. It's a hyperlink back to the model. So it's there. But creating this material passport is key, because again, we need to make sure that when something goes into a building, that we can track it, we can maintain it, we can identify when we take it out to reuse it. And then also, that also feeds into that circular economy. And one of the most surprising things that we found when we looked into this was there's a lot of value that can be gained if we build to disassemble, because there's value in the buildings. So as I mentioned at the start, that 95% of the value of the building is lost when we do the demolition, so when it comes back down. So we can gain value. So there's basically, if we say to people there's money on the table, people will listen. So there's definitely money on the table if you design to disassemble. And as I said, this is something that popped up recently with us on a research topic as well, and it's something that we're going to look at in more detail. But it's there. Fundamentally, we have the virtual tools You know, we have the 3D model, we have the construction simulation, we have the databases or the material databases already there. So we just need to fundamentally look at and change how we design and how we construct buildings. And then, as I said, the guidance documents and the standards ISO 20887 is there to enable us to bring this forward. So, Al, thanks very much. Yeah.
Oh. Yes, sorry. Joel, thanks very much. How we can design for disassembly, very interesting. Joe, you mentioned how we can build quicker and faster. I think modularization has a key role to play. Design for modularization is a key point to take forward. But not only faster, I think we need to build smarter, greener, safer, and leaner. So there's many other aspects to look at as well. So Joe, fascinating. Thank you so much. It's really, really interesting. And our next speaker, my colleague Avril Behan, Director of Build Digital Project, will talk us through the operational energy phase of the process.
Okay, good morning everybody, and thank you Alan, and I suppose I'm going to link together a little bit from what has been said by other speakers and kind of lead into what Michael is going to be saying in the last section as well. So one of the things that Alan mentioned at the outset is that there are a significant number of government policies at the moment that are working towards driving, I suppose, this change that we know we need to make in terms of having the impact. And I suppose what I just wanted to highlight here out of the Climate Action Plan is the elements of the Housing for All strategy that are really important. And I imagine this has been talked about quite a lot over the 2 days of the SEI show here. But it was really important here is to note that there are targets within the Climate Action Plan specifically around homes and buildings. So to an extent, some of the things that Michael was talking about before, because you're talking about large commercial buildings, there's a lot of expertise that is there within Michael and his team. And when you look at a commercial building, you're kind of going, okay, well, that's doable at that scale, but how do we bring that to the 30 to 36,000 new homes that we actually need to be able to build in Ireland to meet our social needs and our growing population? So I suppose within the Climate Action Plan, we have these targets and these supports that are available to us for homes and buildings. So for instance, you're talking about driving energy demand with the National Retrofit Plan, and I can see just looking around the stalls here that there are a number of supports and products, etc., that are helping, as well as training, etc. Loans, grants, SEAI themselves are giving significant numbers of supports here, but it's really about, I suppose, opening that door and letting people know and realise that they are available to us. The training centres, and I know Minister Harris there yesterday was only tweeting again about the Limerick National Retrofit Centre becoming available, and that there are expanding courses and training, and I'll refer to some of those a little bit later on as well. But it is about that decarbonising of our heating and cooling systems as well, but also looking at alternatives like our heat pumps, our district heating systems, etc., and all those new technologies that are available. And how we actually, as Joe exactly pointed out, we need to change the way we think about these things. Not that this is something to be handled after design, but it is handled during design, during construction. We all have that same mindset. So coming back to, I suppose, the topic of this particular talk and the fact that BIM can be an enabler on this, just like to remind everyone, and there's a few people in the audience who've heard me speak about this a few times before, a lot of people still think of BIM as just being that 3D model. You can see from what's been said here before, BIM is actually an information management system. It is a holistic set of tools. It is a way of thinking. It is a set of processes. It's not one piece of software that allows you to have all of your information. It's about connecting lots of different software, lots of different tools, lots of different plans together in that holistic management system. And it's all about getting that flow of information. And in the UK, this is being talked about obviously as the golden thread of information that is actually coming through. And Joe mentioned as well, in terms of that materials passport piece, it's about knowing about all of our products, all of our information, how are they actually tracking through an entire asset life cycle, from inception right the way through to end of life, or as we keep talking about, reuse and repurposing. So within BIM, we have a range of standards, the ISO 19650, etc. And it has within it, on the outside, you're talking about what are the operational targets we want to achieve. And Michael gave a really good example there of, the targets, the KPIs that DAA are working to. Then there's the how we actually do it in terms of what the project is actually going to do. And then within that, it's like, who is going to take responsibility for what? What does each individual or each stakeholder party to the process need to go along? So that image there that you have on the right is actually from the ISO 19650 standard. So the standard is there, we just need to make it interpretable for everyone. So if we look at, I suppose, the what does your organization want to achieve, it really is about that piece of trying not to just look at your compartment or the particular stage within a project. We need to start taking that full life cycle approach. And our colleagues within the Irish Green Building Council, working together with LCA, which are a software development tool, they have created this life cycle analysis tool. It is very easy. There's a free version of it that is available. We can all do this in terms of any designing work that we're doing to actually start to think about the components we have, what impact they are going to have over the full life cycle. Because we do know that, unfortunately, quite often there's a focus on what is the capex, so the capital cost. What is it going to cost to actually build this building? But as Michael showed with his iceberg diagram, that's only the very tip of the iceberg. We need to look at what it's going to take further on. And I suppose there are other things that are coming down the track, and Alan mentioned it in some of the statistics earlier. We're talking about carbon budgets being allocated to buildings. So at the moment, there is a process of discussion going on in government saying, okay, we know we need to reduce our carbon impact. How much of that is going to be assigned to buildings? How much of that's going to be assigned to agriculture? Some is going to be assigned to transport, etc. So we will have those targets that we have to meet. So it's important that we keep an eye on those and keep a monitor on them. And of course, it comes in with, as Joe was mentioning, that statistic about the waste when we actually destroy a building or we take it apart. Managing that waste is another huge factor. So we want to try and reduce that as much as we possibly can. So in terms of that how piece, again, Michael's example for earlier on gave us a really good picture of how we do this. It's not just about the tools. It's about having actually policy targets as to what is it that you want to overall achieve, and not looking at it in the short term, but looking at it in that longer 50, 80-year life cycle for your individual building. And it is, as I say, it's about that information flow. So previously, I suppose a lot of design or a lot of work would be undertaken where the tool allows me to do this, or the software allows me to do this. We can no longer be constrained by that. We can no longer have a system where we can only do it because the software allows us to do. We need to make that connection. And to be fair, there is an awful lot of work going on with standards bodies like the NSAI and also internationally to connect together our data sets and make sure that they can be moved and flexible within. The one other thing I suppose that I just want to focus on is that we do need to learn from behavior. So Michael mentioned as well earlier that we create these designs of our buildings, but is that actually what the building performs like? So this whole piece of post-occupancy evaluation, learning what it is that our users actually do and how the building performs as it is shown. So if I just go back, just go back there for 1 second. In terms of user behavior, the statistics show that the same house, for instance, occupied by different people can have 2 to 3 different factor of energy usage. If you educate your users as to how they can actually use their building properly, and I mean this in housing as well as in commercial buildings, you can achieve anything up to a 14% reduction in energy costs. The user behavior can actually be a bigger factor than external climate conditions. I mean, that's a hugely powerful tool that we have, and we have, with analytics and machine learning, we have that possibility that if we use the sensors, like Joe says, where we put sensors into the buildings, we find out what patterns there are, we can help to educate ourselves as to what the behaviours need to be. So in terms of who and when, it's a case of we have, the clients, all of our supply chain need to be educated in this, and there are lots of supports that will be able to do that. There will be lots that actually can help you. And I just want to finish, I suppose, by just mentioning a couple of supports that are here and available and ready for anybody to use and for different stakeholders across the process, whether it's users, whether it's clients, designers, constructors, craftspeople on site. There are a range of different tools that have been funded by either the EU or by local Irish projects that actually provide supports. So at the moment, our colleague Paul McCormick was supposed to chair this session. He's not here because he's actually at a partner meeting in Europe on a European project that's actually looking at skills development and providing a range of free tools called the Arise project, which will give supports for people for just-in-time training. This is not about you have to commit to a 2 or 3 year program and you have to spend all that time learning, although that's really well, that's good training for people to do as well. But we also know that there's that just-in-time piece. How do I do the task that I need to do now, do it well, and make sure I do no harm, that I am actually saving energy on it? That's what the Arise project is about. You've got other ones, BIM Zeed, which our colleagues in TUS, so the Technological University of Shannon, have been involved with. There's the DASB project, which is funded by Horizon, or the Human Capital Initiative, producing a huge range of new training programs for everybody across the different stakeholder areas. The IGBC I mentioned as well, they have a range of supports on their website. And then the Build Digital project, which myself and Alan and a range of colleagues are involved in. And in that project, sustainability, as Michael said, it's the #1 agenda item. And we are producing supports. For instance, there's going to be a digitization for the circular economy toolkits that companies are able to use so that they can upskill their workers, they can help, and they can be able to do it. So happy to talk to anyone about any of those projects at a later stage, and I'll hand it back now to Alan.
So many quotes there in that talk to refer to. We all need the same mindset. We all think of BIM as a 3D model. It's a way of thinking. It's about connecting tools. It's about the golden thread. And really, when you think about it, the topic we have this morning, energy sustainability analysis is legislated for, but BIM is not. So the message to government and to policymakers is we absolutely need a motivational mandate to say BIM must be used on construction projects to enable a sustainable future. I don't think we can wait much longer for this. This is what is needed, and it is needed urgently, because this 3-letter word is very important that we look at this and make a move in that direction. So thank you, Avril, for the insight in regard to the build section. So moving to our last speaker, and Michael's going to take us through, I suppose, the end game. We're producing buildings that must be more sustainable in the way they perform. If we don't produce buildings to be more sustainable, we're going to add to that 39% that I spoke about at the beginning. So Michael, over to you.
Good morning, everyone. Confession, I am not a BIM champion. When I started in '96, it was pens and acetates and ammonia prints. So we've come a long way since then. I suppose I'm the chairperson of the CIBC Ireland region, representing consultant building service engineers, manufacturers, etc. And also my day job is head of building services and energy utilities in Nui Galway. From the point of view of what we're talking about today, a lot of it's going to be focused about Nui Galway and what we are doing in our journey, but also bringing in some of the aspects where CIBC is involved in some of our linking in with those guys. Just to give you a bit on the Nui Galway, as you can see, our beautiful quadrangle building. Sorry, excuse me. And basically, we have 19,500 students on a daily basis, roughly, over 3,000 staff. And as you can see from the diagram on the right-hand side, we're basically in the middle of Galway. We're in the heart of Galway, situated along the Corrib. Beautiful campus, and as I say, we have over 250 acres. It's basically 3.5 kilometres from one end to the other end. So it's quite a large campus, and I look after 126 buildings in the campus, but also in Sligo, Gweedore, we have buildings in Shannon, etc. They're talking about other buildings as well. So as you can see, we are continuously growing. We have a big infrastructure projects coming over the next 10 years in terms of renovation of a place called Nuns Island, which is right directly in the centre of Galway. So we're going from our original building here, the quadrangles, they say 175 years old. We don't rate it because it's a historic building, which is good, but we do have a lot of renewable technologies in it. We do have wood pellet boiler for the heating. We actually repointed the whole building in the last 2 years, and we've seen a massive reduction in our energy by just doing that. We can't change the windows, it's too expensive, but again, it's from the point of view of a building, it's fantastic. So moving along, I'm, as I said, head of energy, and our energy policy is signed off by our president, because that's where it needs to be. If you want to basically serious about energy, you need to have the highest level of the organisation, whether it's a public sector body or it's a private body. It has to be the head, has to be it. So on a monthly basis, we meet him and report exactly what's going on, and then we have annual reviews with the university management team. From that as well, we are ISO 50001 2018. We've done that for the last 10 years. And as Alan mentioned earlier, the government have set targets as part of the Climate Action Plan, and glad to say that we reached 54.2% reduction in our primary energy from our 2006 baseline. We rationalised that by saying COVID take away 7%, so we're at 47.2% of our primary energy. So we've done a lot of work over the last, I'm there 7 years, so that was my focus. So since then, we've been really focusing in on it. What we're trying to do is, Nui Galway set out a strategy probably 2 years ago, 2021 to 2025, and basically the importance of sustainability with the 4 key pillars: respect, openness, and sustainability. And the other one's gone out of my head at the minute, but it shows the importance of sustainability. As a university, and as everybody knows, people going to university, when someone looks up at a university, the first thing they're looking at now, students, is that university sustainable? Has it got a sustainability policy? Has it got all the links? And if it's not there, it's flicked to the next one. So that's how important sustainability is, as both what we do and how it operates. We were looking at it from the point of view of, right, okay, let's look at our own strategy, and we do have a group called CUSP, and which looks at anything to do with sustainability university, but my side is the energy. But we have a thing called, our motto line is live, learn, lead. I have 19,000 people as a resource on a daily basis, and 3,000 people that are all eager to reduce energy. So that's the resource. Like, as Avar was saying, there's courses, but everybody's doing it now. ESB bills going up, everybody's doing it. Water bills going up, gas bills going up. So the resource is there. So everybody's saying, oh, nobody's thinking about it, but they are. They're doing it at home, they'll bring it to work. So that's what we've been trying to do. Again, the technologies around here, we're not going to recommend technologies unless we've used it ourselves. We've every technology at the university. We have heat pumps, we have solar PV, we've looked at fabric. The only thing we can't do because of the river is put in a wind turbine. We really want to put a wind turbine, but because the river is protected, we can't put it in terms of that. So that's the only one that we can't sort of talk about. Again, what do students want? Information. They just want information. They want to know what's happening. We have energy students. There's 1,500 people in university doing energy engineering degrees through different civil and everything else. But first year, everybody does the topic of energy and everything else, okay? So we lecture quite a lot to them. So we have what's called, we had a silent building management system throughout, but it wasn't doing what we needed. We needed to do something else, so we brought in an overlap one that's at the top called Tritium. So as you can see in the right-hand side, that's sort of like that's a heat map for us on the diagram on the right-hand side. So we can see what's happening, but that's live to the students and staff as well, so they can see what's happening. We produce these graphs then that they can log in if everybody just ducks ahead forward. Each building, we're telling them how much water they're using, how much solar is being generated on their building, how much carbon is being produced as well. And we're in the process of updating the right-hand side, a map campus like that, showing the daily carbon in the building through fires. So again, it's all about information. And where do we get that information? Before, it was Excel spreadsheets, it was, whatever information. But that's why we took the journey about 2 or 3 years ago, saying, right, we need to look at the BIM and try and integrate that in. In terms of, and as Avril says, it's not just about a 3D building, there's so much information. It's all about information, get the data across, and it's, again, we have, I think it's 10,000 roughly pieces of asset equipment associated with all these buildings. It's a high research intensity. And another topic we're talking about later is COVID. And when COVID happened, everybody goes, sure, turn everything off. Yeah, we're leaving our buildings, everybody out. But that's not true for a research building. We can see from our graphs, we only dropped about 30% on our whole campus because with such research intensity, and that's where we need to figure out how can we reduce that intensity. So again, we're looking at preventative maintenance. We're also looking at the efficiency of the equipment that we have, how we specify it, and I keep harping back, but we have students that are knocking on my door every day. I want to do a model list. Can I do it? Yeah, well, there's the drawings. You go and come back to me and let's talk about it and try and develop the whole sort of infrastructure, because it helps them that we are a living lab. We're basically saying our campus is living. If you want to learn, come and learn with us. You can take the building. I'll give you the drawings. I'll give you the specifications. I'll give you everything, and you come back to me with the model. They're coming back with IES models, they're coming back with Revit models, and they're saying, we can build all these things for you and give you as much information as you need. So, as I say, the BIM smart buildings, as we call it smart buildings, but it's the knowledge transfer from, I suppose, our as we call them, the partner students. We call them partners now because they're not colleagues, they're partners with us. So, I pay the bills. I have a bursar on top of me, and we basically get finance to them, so we're paying the bills. So our object at the minute is trying to reduce our bills as much as possible, and through the information and the gathering of all the bills, it's basically, right, reduce energy, reduce your bills. Not working? Yeah. So again, thermal analysis, and I'm going to show a few examples coming up about thermal analysis. One of the most important things we all think about is, in our daily job, and especially even in the office, is the thermal comfort within that space. So we're using the models now to basically go through all our existing buildings with the students and say, right, okay, and just as Michael said about, look at the thermal modeling, look at ventilation, look at how we can, airflow patterns and stuff like that, and what's the way we can reduce and make the space more comfortable for the occupants. Lessons learned. If you don't keep a black book, you're not going to learn. We all make mistakes. We should acknowledge mistakes we make and how we develop them moving forward. So we always encourage students, and even my own team, whatever, that, look at where things went wrong before. My philosophy is keep it simple. They hate saying, like, when I go in the meetings, they hate me when I go, why? Why are you doing that for? Why? It's like, challenge them. Just always challenge anyone that's coming in, like, because I'm coming from the design, now I'm the operator, so I'm going, why do you want to put in all that equipment for? Like if we look at recently the document issued by CIBSE and TM65 on the embodied carbon of M&E, like the amount of mechanical, electrical ducts and cabling installed in a building and the carbon footprint alone of that, if we can reduce it, and one of the philosophies we have is, keep it simple. Let's bring the pipes in a straight line. We don't have to do all this here. So like amount of energy, to pump that from, like, we had an example of a project where someone said, we're going to put the pumps away over here and we're going to put the boiler house over here. Like, well, why would you do that? Can you not just bring everything over here and keep it centralized? So it's about changing people's mentality of how you design. Keep it basic. That's another way of reducing carbon, is if you keep it simple. And in terms of suppose that's experience, but the black book, I have a black book and it's like, oh, that mistake was made. We don't do that again. And I think if we all have that philosophy, we should be all right. Again, fabric behavior. There's no point putting all these expensive pieces of a kit in unless you're looking at the fabric. If you're not looking at the fabric, there's a waste of time. I call it the T-cozy. So we get a building, we put a T-cozy over it, and we protect it. We can reduce our heat pump, we can reduce, obviously decarbonising their buildings. But again, philosophy, keep it simple. Look at all the fabric first. And as Joe was saying about, tagging materials and stuff like that and rebuilding, like that's the process, but we need to be thinking, get in there, look at the fabric and see, is it windows, is it insulation, and see, is it practical? So that's where we're looking from that side. Data measurement. We have 485 digital meters in our buildings that's constantly giving information. And it's constantly giving information of separate about sensors, CO2 sensors, everything else. A lot of information coming in. We have 2 people full-time in BMS watching. And if there's a spike, what was the spike for? We didn't understand, why is that spike? And then you go to the building and you say, why did you spike? Oh, well, I was doing a research project and I left everything on. Why? You didn't tell us you were doing that, Let's look at different times for doing that type of thing. So again, it's that knowledge. And finally, data collection. Doing reports, letting people see what's going on, give as much information out there, because we had an event there before Christmas. We called it the Christmas 12 Days of Energy Christmas. We were advising people on a Monday, turn off the radio, turn off the lights, whatever. But while you encourage people to do that, you have to go back and say, well, this is what happened. And if you can go back and say, look, over that Christmas period, doing that exercise, we saved 30 tons of CO2. That's what people want to see. They're not, if you don't give them figures, they're just going to lose interest, So, but again, we do that through, if you're doing it at work, you'll do it at home and try and do that as well. We were lucky probably 2 years back now, just before COVID, to be involved in, with the SEI and the HEA on a Pathways project. So a lot of, as I think Michael was saying it there, the U9 is the university managers, energy managers. We all meet on a monthly basis. We talk about different projects, how we reduce energy in the sector, etc. And we were lucky enough as one of the Regional Pathways project to look at how we decarbonise our buildings for the public sector. It's a pathway, and it's been an interesting journey, because what's happened is that I've paralleled this. As I said, we are a research, we are a learning institution. So what we're looking at is what's called here the RS, the Broom Building. It was 1970s. And it was basically F-rated. So we're looking at this from a whole holistic. We're looking at the windows, we're looking at the roof, we're looking at the walls, but we're also looking at how we heat it. And it's a typical, 2-sided building, bit of natural ventilation, some mechanical ventilation on the roof. We found that when we engaged with the occupants, there was a bit of nervousness about what we were doing. Why do you want to put all them sensors in for? Why have you occupancy sensors in? Why have you CO2 sensors in? And are you watching me? So I was like, so be careful with sensors and where you place them. But on the left-hand side, we 2 master students, we've employed them, and they've come up with the models, and they're looking at how these boundaries work. We position sensors as part of that. So whilst we're doing the decarbonisation project, we're also doing a research project with it. We're looking at how the heat pump operates. We're looking at how the system integrates. And as I said, we have 126 buildings. At least 80 of those buildings have to be refurbished before 2030. So this is where we're going to make our mistakes. This is where we're going to set up our platforms. So using the model, to build a model to simulate what's going on, what we've done is we did a paper-based. I always like to do the paper-based first and do your calculations. Then we got the students involved, and they're looking at it from a point of view, let's model. There's the heat pump going in. Now the heat pump is going in, so then we look and see do they all marry up of what we've calculated, or are we doing better? I assume we're going to do better. We did an air tightness test, very surprising. It was the building was airtight bar a disabled door that was at the back was just badly sealed. And again, we've looked at the holistic thing, the fabric, the air tightness, the thermal camera, some interesting stuff. So it's an interesting project. Hopefully by next summer, we'll have our first results back from it, and I would say it's going to be a positive. So we've learnings from that. going on learning commons. This is 1970s building library in Nui Galway. And as Joe was saying, this was about in terms of life cycle and reusing buildings. This structure was built by Scott Tonlin Walker. It's basically, it's probably 3 stories over a large basement, and it's quite an energy intensive building. So with the design team and with our own team and our statement of fundamentals and all the way we're setting it up, we're looking at all the different international standards to see this is our document now. So this is our Bible, our resource for any of these projects going forward. It's actually been a very interesting project so far. And the most important thing is the people that operate the building are engaged. The occupants, the librarians, they're so engaged in this project. They're even talking about the BIM models, and they want to see what's going on and how can they change it and can we learn more of it. And we're going, yeah, come in, learn. Like, it's all about learning. Like, that's what we are. We're a living lab, and we just want to keep, moving on. The interesting one is the soft landings that we're looking at now. What happens after? How do people operate? The word that was used probably up to about 2020, maybe it's still being used, which I hate, is value engineering. Value engineering in terms of taking out the renewable products. Like in terms of like, okay, we need to save money, we're not putting the PV or we're not putting it. That's all gone now. The statement of fundamentals and even coming through the restructure, it's there. It has to stay there. We have to decarbonise our buildings, where before it was a line item that could go very quickly. That mentality has to stop. So our next project, which is it's actually a new building, so it's reflecting back, and we're working with the team in JGR Radigans and with Tierney and IN2, and we're looking at how we can make this student accommodation better. We totally reconfigured the boiler house. We've made it more simpler. We're looking at a heat pump technology as our primary, and again, we're looking at the fabric, how we can reduce. So again, it was fabric first, then look at what we need. So from that point of view, it's been really interesting, and we have more students involved, and they're building models. They're linking. We're trying to actually get the design team to bring some of our master students with them, so they're incorporating the design and linking up with everybody and seeing what's going on. So that's me. So thank you so much.
Thanks, Michael. Really, really interesting. The fact that you have a living lab is so rich, isn't it? And it's actually something that will feature in our Build Digital project, very much a focus. As you know, many of you might know, Technological University Dublin are building a campus in Grangegorman, and we're hoping that we can leverage that. People who operate the building are engaged. Wow, that's fantastic. The librarians know about BIM. That's amazing. And the fact that energy policy is signed off by our president. Wouldn't it be interesting to have energy policy signed off by clients? And clients say, well, you said you're going to give me this smart building. I'm going to hold you to account for this because I want to play my part. That's really, really interesting. So ladies and gentlemen, we've come to the end of the presentations, and we're going to have some questions and answers now. Just before I'm going to remind you of this cycle that we talked about. So we talked about potential energy, predicting what we're going to save, and the importance of planning for that. And we heard from Michael in respect to that and the great work that's happening in the DAA. We heard about embedded energy from Joe and the need to be, I suppose, conscious of the materials we use, the passports, think in a circular way, build to disassemble, build to assemble. And that looked at the whole sort of design aspect. And there's been a lot of discussion at the moment about off-site construction. Can we build more on the factory? Yeah, sure we can. We need to industrialize this industry and bring it to site and assemble it, and also disassemble it at an appropriate time. We heard about the whole operational section from Avril, and that we can really make a contribution at the build phase. And Avril really, I think, drove home what BIM is not and what BIM is and how important it is for everyone to think about this as the enabler. And of course, the whole digital construction area is so important now. And then we heard about, the whole sustainable energy. So we're producing a building for 50, 60, 80 years. It has to perform in a smart way. And I think Michael gave us a really good account on that. And of course, all of that collectively, if we go back to the very first slide, 39% of buildings contributing to the CO2 emissions, and 11% of that, really, as an industry, right from planning through to build, we can make a contribution to drive that down, decarbonize the industry, capture the carbon, and really make a big difference. And of course, that's about the hidden, like as a quantity surveyor, I cannot see carbon. I can see concrete, I can see steel, I can measure this. I find it difficult to see carbon, but we need to drive this embodied carbon down. Use renewable energy, use renewable materials, and work in a leaner, smarter way on construction. So we're almost become like the factory of the future in the construction industry. And of course, from the operational side, we need to also make our contribution to reduce the 39% or the 28% that our buildings add to it. So ladies and gentlemen, I have some questions for our speakers, and then we're going to open it up to the audience. I think we're still on time, are we, Pat? Okay. So Michael, in your presentation, you highlighted how planning is critical to minimizing the potential energy loss in construction. Could we look potentially at how digitalization could create an energy envelope for the entire process to monitor, measure, manage, and minimize the entire energy footprint?
Can you all hear me? Yeah.
Yeah.
So I think one of the points I made earlier was that we do need good information. And this is a point that was made a couple of times, is that BIM is not just about models, it's about information. We need really good information about our buildings, and we need to be doing it right now. We're actually retrofitting almost buildings, information into buildings that we've got already, because we don't have that information. So we've got existing buildings, all we know is the bills that are coming in, how much energy that we're using. We don't know why it's using so much energy sometimes, and we've got to figure that out, and we've got to go back in and almost redo all that again. We should have done that first time, but those buildings were built 10, 20 more years ago, and that's the difficulty now, is we now need to get a good handle on all our assets, and especially anyone who's looking after a campus needs to understand every building in that as part of their portfolio of assets, and to understand where best to do those interventions. One of the things we're finding out is basically that the best interventions are obviously on the envelope of the building. So you try and upgrade the exterior. So if you get the exterior up to a really good standard, you need to use less energy. If you can only get to a certain standard, you need to use a bit more energy, and then start looking at then what's the most optimum energy sources you can use, and so on. Or you've got to start offsetting that with photovoltaics or wind energy or hydro if you can do it. And so if you can get the envelope of the building right, optimized, that's the best start, we find. As an airport, the difficulty we have is that there's a lot of intervention, construction on an airport site, and especially inside a terminal building. It's hard enough to get through security without, and we're having issues with that without actually people building as well. So we're really looking at every little detail of that. We know we've got to improve the envelope of some buildings, but we've got to do that in a way that works with the way we work. So what I'd say is the big lesson for me is get it right the first time, and now we need to be doing it right now, getting our buildings as right as possible the first time, and also then making very good records of the information that we have, so we can actually then understand then if we want to do anything further to that building, we know what we're doing with it. And I think as Joe has said as well, the big thing is this recycling of what we've got. That's going to be just absolutely big. So I believe everything we're building at the moment, I'll be very surprised if we're taking any of it down. So get it right first time is my message.
Thanks, Michael. Thanks. Interesting. And I presume, like Michael, you're also monitoring your buildings.
Yeah. We're monitoring our buildings. Where we have sensors around the buildings, and what we're doing at the moment is we're looking at, and I showed you the last slide, that's the main Terminal 2 building. That was only completed in 2010. So what we're doing at the moment is we're monitoring that building to see how it's performing at the moment. We know it's not performing as we wish, and definitely not going to meet the targets in 2030. So if we do nothing, we're in trouble. So we've got to intervene basically, but what we're trying to do is to use the data from that monitoring to use that then to bring that into the virtual model that we're building. We want to get the virtual digital model to match the actual existing model. And once we're comfortable that they're a match, we do our interventions. We then monitor to see then is those interventions working. And if it's slightly off or it isn't working, we'll look at the model again and try and get that back onto a line. But we're really, that is the absolutely key important thing we need to do. And one of the things we're looking at as well is how we do all this reporting. And so where is this data going to be? We don't want this in silos. I don't want to see it basically in some engineer's computer and he's got all the data and I have to go to that person, whoever it is, and get that information out of his or her computer. I want that to go right up to the top. So what we're doing is we're putting all our data into a sort of a central data hub, and then what we're doing then is starting to look at then how we get those reports to the right people who need that information. So we need to get that as live as possible. We need to get it directed, and we need to really look at who needs to see what information. So that's going to be really critical.
Thanks, Michael. Yeah, that's excellent. Joseph, you outlined the tools designers and architects have now at their disposal, you know, to design in the design phase, to minimize, I suppose, embedded energy. You know, historically, the hidden energy losses in a building that were never captured and minimized. How critical are these tools to set the bar for energy performance?
In terms of energy performance or, you know, total life cycle?
Well, I mean, you have a piece of software that can predict energy
Yes.
use. How critically important are they?
Well, we have to take each instance, you know, if we're dealing with retrofits, there's one instance on Michael speaking about retrofits. So what he's saying is we need to baseline what we have. So we need to go in and take a snapshot, a current state analysis of a building. So we need to point cloud scan the building because we need to know what we have. So before we move forward, we need to know what we have. We would scan, we would document and track and label. I suppose that's what's happening for you guys at the moment in terms of trying to see what we have. And then once we know what we have, then within a retrofit instance, we can move forward. Yeah. But in terms of a new build is where there's a lot more opportunity because we can make changes within the virtual environment. So we can, as the guys mentioned, we can create a model, we can look at different instances, we can run different simulations, we push the information out to IES. But again, once we can make changes and modifications within the virtual environment, and there's no cost compared to trying to make a change in the physical environment. And it's about, again, going back, it's about fundamentally changing how we design, how we look at it, how we value the way that we want to use our buildings at present, how we want to use them in the future. So I think, you know, there is a lot of softwares, there's a lot of tools out there to use in a retrofit scenario, but there's also a lot of tools to use in a new build scenario.
It's probably fair to say that the technology is there, it's just that maybe we're not using it as much. I mean, if you look at the EVs outside this room here, do you think do you think that they were not tested, you know, that they didn't produce a digital twin of those cars before they went to manufacture? Of course they did. Everything was tested at the design phase before they went and built it. And they were probably built by robots. Now, I'm not saying we're an automotive industry, but we need to move more towards an industrialized future if we're to get the benefits. Yeah. My own son, by the way, works for Lisley, and yesterday Ethos Engineering came in to talk to them about digital twins. Nobody in the room knew about digital twins, and these were property companies. Yeah. Astonishing. So the property companies are selling, leasing these buildings, and they don't know the potential of BIM. Now, maybe that, so it's really there's a communication issue here. Avril, more than ever, we've got these rising energy costs. How critical are these skills, these energy skills required in construction to ensure we close this gap between what we predict and actually how these buildings perform?
Yeah, that's a really good question, Alan. I suppose, I mean, I think the thing is that actually our design teams, I think, are doing reasonably well. I think they, you know, I suppose maybe part of it has been because policy has actually dictated that we do need to upscale, and there has been a significant amount of upskilling on that part. But it is, as you said there, Alan, with the Lisney example, it's the downstream learning that's actually needed. It's the clients who needs to know. It's maybe, let's say, some of the staff on construction sites who need to know that, okay, it's not going to be enough if I install this piece of insulation, but then I drill a big hole through it and I, ruin the U values or something. Or similarly, we would have had a situation in the past where, let's say, our building manager decided, yeah, we can absolutely reduce our energy, but all they did was turned off the heating and everybody was, sitting there shivering and unable to do their work. So there are pieces of learning that need to be done, and I think the thing is that it's up to us in the education sector and for us on the Build Digital project, for instance, that we actually open the door and showcase that there is learning available, there are materials, there's a lot of money being put into it by both the EU and by the Irish government to actually help educate people. And it's at shows like this and at other events where we need to actually make people aware that there is support, there are tools there, there's things like the Springboard program, SkillNet, etc., where companies can get themselves upskilled and they can actually get the learning that they need. So absolutely, Alan, it's important, but it behoves all of us to actually keep spreading the word.
Thanks, Aaron. Michael, you talked a lot about the living labs in NUIG. Could you just talk a little bit more about that? And you give some quite impressive figures on savings. So just remind us again, from 2006, is that right?
Yeah.
To 2021,
Yeah.
you saved 47.2%.
47.2%.
Of what?
Our primary energy. So basically, our electricity, our gas,
Spend.
our fuel. So our spend. So basically, our primary energy. So now the fact it's with our colleagues in SCI, we're looking more at our carbon now. So looking at our carbon footprint, looking at how we can reduce our carbon. But just as Avril was saying, as a client, we need to understand what's happening before we ask our professionals. So that's where, with our own team, we want to know what the heat pump does. So our team went off and did a course on heat pumps, installing heat pumps, not just learning about them. So before we ask, and it's always a philosophy, before you ask, understand it. So as a client, it's important. But professional side, there is so much information out there. There is different programs, there's different funding. And again, professional bodies like CIBSE and Engineers Ireland and ASHRAE, there's a lot of development going on that can basically challenge all these things. But my primary thing is that you need to ensure you know what you're asking before you ask for it.
Yeah, absolutely. Sorry for the interruption.
Sorry, I didn't want to brag. I didn't want to brag, but we're actually ranked 14th in the world in all universities for energy corruption. So
I think every household in the country.
I didn't want to brag with that.
I think every household in the country will be interested in the 47.1% saving their energy bills, I can tell you. Yeah. So, ladies and gentlemen, I'm going to open it to the floor. There are two mics here. If you have any questions, you might just stand up. Hopefully the mics will work and maybe address the audience, address the speakers, yeah? Want to just try it, yeah?
First of all, thank you very much for these presentations. And then, my name is Mustafa, I'm coming from Cyprus. I want to hear your opinions about
Okay, that's okay.
about
We're just getting some feedback. Okay.
yeah,
All
it's
right.
fine now.
Yeah.
I want to hear your opinions about the green building certification systems like LEED and BREEAM and the importance of them, because currently I'm pursuing to become a LEED AP, so I want to know the importance of it for the building sector. Thank you very much.
Yeah.
Do you want to take that one, Michael?
Okay, I'll start off. I suppose we are at the moment looking at both LEED and BREEAM for our buildings, and it'll depend on what building we're looking at as well. Now, my experience is from working with these systems before, I thought they were absolutely super, because what they do is they give you basically a point system, and everything gets a certain amount of points. So you need to focus on basically where you're going to achieve those points. So, but they crisscross everything, not just energy. They crisscross things like bicycle storage, and they differentiate things like, let's say, covered bicycle storage from non-covered, and you get more points for the ones that are covered. because you're actually going to get more people to actually cycle to work. They'll look at the proximity of those cycling to the actual building and then actually to any potential sort of changing rooms that you have. So they're looking at it, I suppose, from a wellness point of view, but they're promoting good policy as well for how people not just use the building, but actually interact with the building from their home or visiting the building and so on. So I worked in an architectural practice for about 25 years, and that where we use LEED and BREEAM standards, they put a focus for us on basically what we needed to do. And what we ended up having was basically a person, well, there's a couple of people in our office that basically became sort of experts on those, and they kept a track of that. They had basically a checklist of things, and they'd say, look, on your design, how are we going to get to the 80 points or the 70 points or whatever it was, depending on what it did. And what it actually did was it actually gave you a kind of a strata you could achieve. So you had it's like exams. So you could get, if you got above 60%, you got a certain mark, 70 another, 80 you're into the sort of excellent range. And that gave you a kind of a way to say, look, let's head for the 80 if we can, and if we don't get value engineered to death on this building, but we have options then, where it's all's not lost. And that keeps a focus on everyone then, because they're thinking, right, I've lost a couple of things, but I'm still going to achieve this next one down. And we got the top one, and in some cases, that was less achievable than we thought. And it's back to, again, everyone has great aspirations at the beginning, and they can get easily lost, and that I found that they just kept it on track, and I thought that was excellent. But from a client's perspective, and especially if you're trying to market a building, if you've got LEED and BREEAM, that's very marketable now. So if you're going to lease a building or to an office building, and you've got one that's LEED and you've got another one that's has no credentials, it's a completely different kettle of fish. You'll pay a bit more for that building, because not just for large corporate companies who are trying to reduce their carbon footprint, that's a massive positive to them. So it's extremely marketable. So that's my experience of it.
Thanks, Michael.
In terms of the LEED and BREEAM element as well.
Yeah, have you got a mic
Yeah,
up
I think
there?
I should have one there, yeah. Just in terms of the LEED and BREEAM element as well, I suppose, coming from the commercial sector, as I did, I think people initially, when it came into the country, and I think it is a very good point, it was the first time that people did concentrate on sustainability, but there is an impression, I suppose, that it's just purely concentrated on the energy element. So, for example, there is a building energy model that's created, and I think out of 100 points, say, you can get 21 points approximately for your energy model. But that's I suppose the points are directly related to how the building is going to operate in terms of efficiency. So I think there are other elements which is to do with, non-smoking areas and other elements such as this and biodiversity on the roof and things. So they're all overall sustainable, but I think sometimes you may have a building with good LEED points, but it may not necessarily have an extremely good energy efficiency at the same time. So you could potentially get LEED Gold, but have a reasonable energy efficient building, but there could be a number of other elements where they caught the other points. So they might have only got 8 or 9 points from the energy efficiency, but they gathered the other points due to the proximity of bus stops or railway lines, etc. So it's just important, I think, to be conscious of that. Don't get me wrong, it was the first, when LEED and BREEAM came in, it was the first element that made people concentrate really on sustainability, and elements start getting badged. But if you look at the Exceed cycle, for example, that SEAI run, there is a grant involved in it, but the overall element is about energy efficient design through the whole process. So that's actually a certification that a building can get. But that whole design, that whole element is purely directed towards the energy efficiency of the building. So from concept, design, construction, and a year after the building's finished, you come back and monitor it to make sure that it achieved what it needed to achieve. So if you get an Exceed certification, it means it's purely dedicated to the energy efficiency of the building. But LEED and BREEAM are certainly good as well.
Interesting. Any other questions? I was told we have to finish in 5 minutes, so maybe one. Yeah. Yeah.
Hi, my name is Chuka Okoli from ESP in Energy Management Systems. But the question I'm about to ask is not about energy management, so it's kind of forwarded to Joseph and I think Arvel. So I was just thinking about what you said, modularization of building components. It just seems like this is going to change the market, right? So you're going to have like big corporations kind of taking over these sectors, and I'm just thinking on how it will be how it will be brought into practice, because you're still going to have smaller, middle to smaller scale construction companies kind of having a lot of challenges in this sector, and how are they going to kind of, compete with people that are able to just mass produce different building components and, modules, if this is the way it's going? Like, is this also covered in, say, programs, like you said, there are quick programs that people can kind of learn, is this put into, the research, on how people can?
Interesting.
Pretty much.
So how do SMEs sort of operate in a modularized, industrialized future? Any question? Anyone?
I'll jump in on that one. So I suppose that's an area that we work in. We work with a lot of companies in terms of upskilling and digitalization. At the moment, I suppose Enterprise Ireland have grants available. There's two grants. One is the BIM Enable and one is the BIM Implement. And you had to be a member of Enterprise Ireland to attain them grants. And what we would do is we would go into companies and we would basically audit the companies. We would see how mature the staff are, what process they have, what hardware, what software, and we would look at the overall processes within the company and the different departments. So we do work at the moment with clients within that sector with EI, and they'd obviously be at a certain size, and you had to previously be exporting. But there's a new initiative that just came out now by the government that anybody within that I think have more than 10 staff and have 20% of their turnover within the house building or residential sector can apply for a number of vouchers and
it's called Build to Innovate.
Yeah, Build to Innovate. So there is a lot of vouchers, and we would also support with the digital innovation and the BIM Enable. So that's definitely there now to support from a financial commercial side, and we do deliver that. From an academic point of view, originally why we created the digital delivery for site teams was about trying to upskill site managers, construction teams, and project managers to utilize the information, the 3D models and the BIM tools, to be able to view, to be able to integrate, and basically to align to the processes and procedures that they need for their roles within the company. So there is a number of initiatives. There's a number of courses in terms of within academic industry. Also, Springboard is available, which is free courses. So you do have the grants, and you do have obviously the different academic courses that's available. From a CIF point of view, we also, and I suppose I personally work with the CIF, the Further Out Committee, to create standards and guides, and they're available now at the moment, that can support companies on their digital journey to enable them to mature. So there is information out there, it is available, and we have worked on it. So
Avril, do you want to come in there?
Just want to make one comment. I think you were kind of indicating maybe as well, is there a change in the sector? And I think there is. I think there do need to be new, business models. There needs to be more, let's say, cooperative working between companies. So for instance, one of the other things that Enterprise Ireland funds is Construction Cluster Ireland. And that's about getting small SMEs to actually work together in a co-petition type of way, where actually it's not about, okay, I only do this bit and I don't think about what goes on in the rest of the supply chain around me. So I think that is going to be an important element of that as well. So I would suggest that certainly SMEs are looking at their own upskilling, but they're also looking at how they connect broader across the sector, and not only think in a competition way, but think of how do we work together.
I mean, given the enormity of the task of delivering these three plans, housing for all, national retrofit, climate action, there's work for everyone. The problem is there's not enough workers. They can't get the people to do it. So that's why maybe we have to do more in the factory. We have to industrialize this industry more. One more question, and then we've got to wrap up. Thank you very much. The speakers will be here to answer any, if you want to have a chat with them afterwards. Thank you. And I'll just wrap up after that. Yeah.
Hi, Jason Smith from Lawless Sustainability. Just one of your last comments was it would be nice if you could make people accountable for achieving this. I just want to ask people about the concept of the IMVP protocol in terms of taking your calibrated model for a new building or an existing building, using your digital twin and effectively paying the contractor as an energy performance contractor or energy performance related payment. To my mind, that is the real way that you will drive these things, because if you hold the contractor accountable to the actual performance, and even apply this beyond energy, apply this for your carbon footprint as well. Hold the contractor accountable and you will actually have much better results.
So what you're saying is you see that the contractor staying beyond the build phase, building out the facility, but also maybe even managing and operating the facility.
Potentially managing and operating, but actually being responsible for the outcome.
Or making them responsible for the performance. Yeah, interesting.
Exactly.
Yeah, I mean, that's certainly within the soft landings, and I think maybe other colleagues might talk to that. But actually the reason why our host changed last minute is actually that European project we're working on, the Arise project, is actually looking at building in a blockchain solution that can actually hold that responsibility. But I suppose we've got to be really careful about how we do that, because we all know margins in construction are very, very tight. And therefore, if you're withholding funds from organisations until the building performs, that's going to be a difficulty. So I think we have to proceed with caution as to how we do it and not just jump straight into it.
Yeah, I think as well.
Okay, well, listen.
Sorry, just behind, I suppose, the
comment.
UK brought in the concept of the soft landings, and that sort of went for 2 or 3 years from the traditional, that is 1 year sort of post handover, and that's the occupancy period. So it extends that occupancy period and does put a bit of onus on the contractor to achieve certain goals. But that needs to be clear from the very start. And I suppose just one of the things I'm doing, I suppose, is we're trying to make sure that in our contracts that those things are all in there. If they're not in the contract, you know, it's up for change.
Michael, thank you so much more. We could talk for this for a long time. So my thanks to our speakers, to Michael Earley for talking about sustainability as #1 priority in DAA. We can't do sustainability without BIM. Joseph spoke about circularity, design for disassembly, material passports. Avril spoke about the importance of BIM, the golden thread, a new way of thinking. And of course, Michael then really bringing it all together, living labs, students experiencing this all together. So I really, really, really enjoyed this morning. Thoroughly enjoyed it. And I'd like to thank SAI for the invitation. My best wishes to Paul and Barry if they're listening in Rome. Enjoy your trip. Enjoy the pizza. I really enjoyed this morning, and thank you, Pat, for your help as well today. So I'm going to hand you over to Tim.
Thanks, Alan. Just on behalf of SEAI, thanks very much for Michael for coming forward to offer up this presentation. It is something we're really excited about and really interested in getting involved in, and we know that all these elements are really important for all of us to achieve our goals. So again, just thanks to the guys for coming forward for doing this. It was really enjoyable, really informative from our side as well. And to anyone else who's out there who has something similar, we're always interested in hearing about new innovations and new plans to get us where we need to be. So I leave it at that. If you want to continue your sustainable pilgrimage around the stands, I'll be having the equivalent of Mass over at 11 in the Minerva Suite. There might be some spaces still left, so that's 11 till 1. So if you want to call over, you're more than welcome. Thank you.